Okay, back. 6.1. Exploring nonlinear relations. Okay, so, new term, quadratic relation. That's an equation that describes a parabola. An equation of the form y equals ax squared plus bx plus c, where a cannot equal 0. So it's that x squared term that's going to be very, very important here for a quadratic relation. And a quadratic relation is, by definition, an equation that describes a parabola. So that we know, we call this a line. This is a line. So the picture of this equation is a line. Therefore, we call this linear. A linear equation because it creates a picture that's a line. A quadratic relation is an equation of this form that's going to make a parabola. Back to our line. This is our line. It makes a linear equation, and notice it's only in x, mx plus b, not mx squared plus b, not mx cubed plus b, but mx plus b, so just a singular x here. Whereas a quadratic relation will be an x squared, and sometimes with an x as well, but it has this telltale x squared term with it. What is a parabola? Well, the parabola is the picture that we get when we graph this, and it's going to be a symmetrical U-shaped graph, and by definition, it's the graph of a quadratic relation. So, a quadratic relation is one type of nonlinear relation, so they're not lines. The graph of a quadratic relation is called a parabola. Alright, so a bunch of things following through there, but it's fairly straightforward. If we think about y equals mx plus b as being linear as an equation, it makes a line when we graph it. If we think of a quadratic, so it's got to have this ax squared term to it. We call that a quadratic relation. And when we sketch it, we're going to get what's called a parabola, which is a symmetric U-shaped graph. So the picture is called a parabola. The equation is called quadratic. The picture is called a line. The equation is called linear. Okay, so that's pretty much what it all boils down to. Example 1. Graph the data in each table, draw a line or a curve of best fit through the points, and explain your choice. So pretty straightforward. 0, 1, 1, 3, 2, 5, 3, 7, 4, 9, 5, 11, 6, 13, 7, 15, 8, 17. And if I had to guess where the next one was, could you help me? Do you know what 9 and the next one would be? Well, this is going up by plus 2, 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 plus 2. So the next one would be 19. So it would be 9, 19. And what happens when you go up by the same amount all the time is we get what's called a linear equation. This is your rate triangle. I went over 1 in my x value, and I go up 2 between any 2 points. I go over 1, and I go up 2. That's my rate triangle. Now notice what happens if I go over 3. So I go from here, 1, 2, 3. Well, then I should go up 1, 2, 3, 4, 5, 6. And it still takes me to the same line. All of these are the rate triangles that's happening between each point. So this is going to be linear. Why did I choose linear? Because it kept going up by the same amount from each point. Let's try the next one. 0, 16. 1, 9. 2, 4. 3, 1. 4, 0. 5, 1. 6, 4. 7, 9. 8, 16. So, I now need to connect these points with the curve of best fit. And I think we would all agree that the curve of best fit looks something like this. Now, if I had chosen values that went this way and chosen values that continued on that way, I think we agree that the curve would continue. So I can put arrows on the end. And up here, I stopped at 0, 1 because that's where I started from, but I didn't stop at 9, 19, so really, I should continue, indicating that I could go on. This is that U-shaped curve we've been talking about, so this is going to be a parabola. So the actual picture is a parabola. This actual picture is a line, which means what? Well, it means that whatever this data came from was quadratic. Now, let's think about this rate of change idea. 16 to 9, that's a difference of, well, 16 minus 9 was a difference of -7. 4 minus 9 is going to be a difference of -5. Minus 1 minus 4, -3. -1. Then plus 1. Then plus 3. Then plus 5. Then plus 7. This is definitely not the same as this one, is it? It doesn't have the same constant rate of change in between each x value. So I move over 1, I go up 1. I moved over 1, I went up 1, 2, 3. I went up 3. I moved over 1 from this point, and I went up 1, 2, 3, 4, 5. I moved over 1, and I went up 7. So what? This is over 1, up 1. This is over 1, up 3. This is over 1, up 5. This is over 1, up 7. There's these values. Those are not consistent like it was here. So it can't be linear. It's going to have to be non-linear, which is a catchphrase for anything that is not linear. But I can tell you even better, it's going to be a parabola, which means it's going to be quadratic. But we'll find out more about that as we move on. Okay, that's the end of 6.1. That's how quick that one went. So these are the differences. This is linear, this is nonlinear, and in fact this is going to be parabolic, I can tell you that, and which means it's going to have this equation. It's going to have that equation where a, b, and c are going to be numbers and a cannot be 0. Okay? It's going to have that x squared to it. Okay, I'll stop here and then we'll move on to 6.2.